Hi guys, my name is Hari and this is Project Directory, where we'll be focusing on technical videos related to projects that I and the OSS community have built. Recently, it has become a trend among my classmates to quickly just whip up a typing test tool like Monkeytype and check how fast they can type under a fixed time. One thing I've observed from that is obviously they're not really thinking about individual keystrokes when they do that. It's more about that flow state, and when they mess up, it breaks their rhythm completely. So the best scores come when they're not consciously thinking about typing. But why does this matter, right? Why are we even doing this? As a means to pass time or for something more? In the case of my peers, honestly I can argue for both sides. It gets boring sitting with next to nothing to do in class, especially during extra classes, where the lecturer lets you free for most of the class. But here comes the question, is it better as a programmer to type quickly to write code? The crux of today's video is just me trying to hypothesize that typing does make you a better programmer. And the evidence that I found seems to support my hypothesis, but not in the way that you might think. We'll learn more about that later in the video. According to an insight I found, typing isn't a bottleneck at all actually. Programmers rarely type more than a few characters before pausing to think, often getting only 10 keystrokes out before having to stop and make corrections. So if typing isn't a bottleneck, what is? Imagine you are in the middle of writing a 200-line function for a server that serves a specific part of the database to the authorized user. You are logged in right now and you are in that flow state thinking about how you need to implement this, considering 1,000 other factors all running in your head. You write a line and remember that this function has to do this particular thing before moving to the main logical part of the function. You gather yourself, move your hand to the mouse to scroll all the way to the start of the function and find the exact line where you have to add this supposed implementation of the idea you just had in your mind. You find the line and add the remaining lines, and once you're done with that process, which probably took 30 seconds to a minute for you to do, you come back to the line where you were already writing the rest of the function in a rhythm. The flow is now broken and you have to spend all that time to gather back your thoughts you had on this part of the code. It has simply been too long to add those lines and get back to what you were doing earlier. Think of it this way. Your brain is like RAM. It has limited working memory. When you're coding, you're fetching from your ROM the problem that you're solving, the architecture in your head, dependencies between components, variable names, function signatures, etc. etc. If you also have to think about how to navigate your file and how to type, that's one more process competing for resources. It's almost like you keep what you need right now to work in your personal cache, and that disruption sets you back to having to reload from your hard drive. So it's not about speed, it's about removing that friction. Writing, including code, is thinking. When there's friction between thought and expression, you lose thoughts. They're fragile. How many times have you had a brilliant idea, started implementing it, got stuck on some syntax error, and by the time you fixed it, the original insight that you had was gone? If you can type faster, then you can operate closer to the speed of thought. It's not just about working faster, it's about being able to clearly express what is in your head. Here's one more argument. Improving typing speed increases chances of writing more detailed documentation and code comments. Obviously, the psychology being if typing feels like work, you'll naturally write shorter variable names, fewer comments, sparse documentation, and code that future you will hate. When typing has this friction, you unconsciously optimize for less typing. It's not like a conscious choice, it's your brain naturally taking the path of least resistance. Okay, let's talk about Vim for a second. Here comes Vim and says that if you think quick, you deserve to have a text editor that moves at your speed instead of limiting you and causing that friction. Vim is a modal text editor, which means it has different modes logically so that every action that you could take in your text file can be done with just your keyboard. In Vim, we mainly have 4 modes. Normal mode, which is the default mode that has your navigation and meta keybinds like undo, cut, copy and paste. Insert mode, which is the mode that we enter using either I or A from normal mode, which lets us edit our file. Visual mode, which can again be accessed through the normal mode, and it lets us select text across the whole file. Command mode, which can be accessed using the colon, and it lets you execute Vim commands like edit and quit. You can go back to normal mode using escape. Vim just asks you to think of text as something that can be navigated spatially, almost like a map, with text broken into logical chunks like words, sentences, paragraphs, and blocks. It is built with the purpose of minimizing keystrokes because obviously as a power user, you spend most time reading, not writing. Let's see how to navigate through your file at maximum speed using Vim. Within a line, W and B leap forward and backward by words, while E lands on word endings. We can scale up to sentences with parentheses or entire paragraphs with open brackets. GG lets us go to the start of our file. For code, the percentage symbol bounces between matching brackets, letting you navigate function bodies and conditional blocks instantly. Visual mode lets you select these chunks. Capital V enters visual line mode, which allows you to select lines. VIP grabs an entire paragraph. VI open flower bracket selects everything inside braces. VA double quote captures a quoted string, including the quotes themselves. You stop thinking move cursor, delete character by character, and start thinking delete this logical unit. Your mental model shifts from character by character editing to flying between landmarks. The file itself becomes a map where you know exactly how to get from point A to point B, and the text transforms from a linear stream into a structured space you can manipulate with surgical precision. Once you can type without thinking, you can start thinking in text operations rather than character by character editing. Vim's modal editing fits perfectly here because A. You're not constantly typing, B. You're thinking in normal mode, then executing in bursts. C. The commands become a language for expressing transformations. Okay, now I've spent the whole video arguing that typing fluency removes cognitive friction, so you can think clearly. Now we need to address the elephant in the room, AI, and autocomplete for that matter. Even traditional autocomplete in some sense is very useful when it comes to filling out and completing what you started thinking. AI autocomplete completes what it thinks you should think next. It is like having someone whisper suggestions in your ear while you are trying to compose a sentence. Which is again pretty nice, right? Even if the suggestions are a little interruptive. That is until you realize that AI autocomplete adds a whole different kind of cognitive load. Every AI suggestion forces you to pause and think whether to accept it, reject it, or modify it. A constant stream of micro decisions that fragments your attention. Seeing the AI's suggestion first shapes your thinking, making you more likely to accept good enough code instead of discovering the better solution you were about to write. AI autocomplete interrupts your flow by forcing you to evaluate its train of thought instead of staying immersed in your own. One developer described it perfectly. When Copilot suggests something, you're no longer writing code, you're reviewing code. That's a whole completely different mental model. Obviously, just like I don't want to type out system.out.println character by character, maybe I don't want to think through standard error handling for the 500th time. AI autocomplete could be for thought patterns what regular autocomplete is for typing patterns. For beginners, AI autocomplete can be a crutch that prevents learning. They never develop those mental models because the AI always fills in the gaps. But for experts might use it like a faster form of copy paste from Stack Overflow. They know exactly what they want. AI just saves the mechanical work. When you type code, you are thinking through the problem. When AI generates code, you are thinking through whether the AI thought correctly. These are fundamentally different cognitive processes. The first is synthesis, the second is evaluation. Both are valuable, but if you spend all your time evaluating AI suggestions, when do you practice synthesis? When there's no friction between thought and text, writing code stops being I know what I want, now I need to type it out, and it becomes I'm figuring out what I want by writing it. The act of editing is the act of thinking. And the wildest part? None of this is actually about speed. You're not typing faster to save time on some hypothetical project timeline. You're removing friction to think more clearly. The productivity boost isn't I finished in 8 hours instead of 10. It's I solved a better problem, or I wrote more maintainable code, or I actually documented the weird parts. Monkeytype is great because it teaches you that fluency. Vim, on the other hand, teaches you how to be expressive. Together, they remove the friction between your thoughts and the screen. Not just because you're typing faster, but because you're thinking in text operations rather than keystrokes and mouse actions. If you are interested in more content related to typing and Vim, check out the top link in the description, where I have provided links for getting started with Vim and NeoVim, and a formal guide to get better at typing faster. They will also be available in the script of this video, which is in the form of an open source markdown document on my GitHub. Link is in the description. Thank you for watching.